So I wanted to talk a little bit about one of the conceptual questions that we had for this last week, and that was the scenario of an elevator going up, let's say, at constant velocity, um, let's say 2 meters per second. And the question is, the person inside the elevator, what kind of acceleration of gravity will they measure? So let me define a coordinate system here. Y is up and X is to the right. We won't be using X, but we will be using Y. And so the elevator is moving up at constant velocity of 2 meters per second. I just picked that number to get something definite. And again, what acceleration of gravity does the person in the elevator measure? So I'm going to use easy numbers and assume that G is 10 meters per second per second. So now let's say that you're standing outside the elevator on the ground. And what you observe when the person drops a ball, one way to measure the acceleration of gravity would be to drop a ball and see how long it takes to hit the ground. When the elevator person drops the ball, you will see the ball having an initial upward velocity of 2 meters per second, up. And you will also see the elevator floor moving up at 2 meters per second. And so let's say, again, just to be concrete here, that the ball is initially 5 meters above the elevator floor. That's quite a height. So the question is, how long will you, standing on the ground outside, observe that it takes for the ball to hit the floor? That will be the same time that the person inside the elevator would observe. So let's assume that at time equal to 0, the y for the elevator floor is at 0. In other words, the elevator floor is at ground level at time 0. And so we can then put a little table together, as you see here. And there's 3 columns to this table. Time, the y of the elevator floor, which is, since it's going at 2 meters per second, that's very easy to predict. And then the y of the ball that you observe standing outside. And so for the y of the elevator floor, that's going to be 0 at time 0 because of our assumption here. And then half a second later it will have gone 1 meter up, and then 1 second later it will have gone 2 meters up because it's going at 2 meters per second up. The y of the ball is going to be predicted by, and this is again the one you observe, is going to be predicted by this equation, which says that the ball is initially 5 meters above the ground, has initial y velocity up 2 meters per second, 2 meters per second times time in seconds, plus 1/2 times minus 10 meters per second per second. This is the acceleration of gravity, and for you standing on the ground, times t squared. And so the equation then is 5 plus 2t minus 5t squared. So the position of the ball at time 0 is 5, and a half a second later it's 4.75. The position of the elevator floor is 1. And at time 1, when the position of the elevator floor is at 2, the ball is also at 2, which means that the ball just hit the floor. Well, this means, though, that you will observe, standing on the ground outside the elevator, that the ball takes 1 second to hit the floor. If you use your h equals 1/2 g t squared equation, you will see that that means that the time that the acceleration of gravity that the person inside the elevator would assume is the same as the one that you observe, minus 10 meters per second, in other words. So the conclusion is, as long as the elevator is moving at constant v, that constant v will not change the acceleration of gravity, or for that matter, any acceleration.